So, good evening dear students, welcome to Maths Bridge course. So, today we will be discussing the topic of integration. This is another very important part of calculus. So, in the yesterday's class and day before yesterday's class we discussed one subunit of what is that calculus, that is we discussed about differentiation, and I told you two subunits are there when it comes to calculus. One thing is what? Differentiation, another one is integration. So, already we have discussed about differentiation, some important concepts also related to differentiation, and also very important key questions also we have solved. Okay. Now, coming to integration, in the first class itself when I discussed about calculus, I told you integration is the reverse process of differentiation. Okay. Now, see here, observe carefully, if I talk about integration, they say integration is the reverse process of differentiation. So, see, if I write d by dx of some function, okay, d by dx of some function, let us say x square, we will write it as what? 2x. That means what we are doing here, what is the process that we are doing here? That is differentiation. Okay, we are doing differentiation. This is the process. Differentiation is the process. Okay, differentiation is the process. And what is the output we are getting here? Output what we are getting? This is called as what? This output is called as derivative. This output, the answer what we are getting is called as derivative. Now what happens is, if you talk about yeah, go get some water. Okay. Now what happens is, output is derivative. Now when you talk about integration, I told you it is a reverse process. So if I write 2x, I should get the answer as x square. If I integrate 2x, I should get the answer as x square. Okay, x square. This is called integration. That's why it is the reverse process of differentiation. So whatever the answer we get after integration. Integration is what here? Integration is the process. Out of this process, what we get the output, we call it as what? We call it as antiderivative. This is called as antiderivative because it is the reverse process of differentiation. See, 2x we got as the output here. This is called derivative. If I integrate 2x, I should get back x square. This x square is what? This is the antiderivative. This is called as antiderivative. That is why this process of integration is called as reverse process of differentiation. Now, what is the utility of integration if you ask me? What is the utility of integration if you ask me? Integration, if you ask me what is the utility? Yesterday I told you that, or in the class of what is that? Differentiation, I told you there is a car moving and it will travel some distance in some time. Suppose I take this as time, this is distance, the car will travel some distance, the curve will be like this. If there is no uniform speed, this will be the curve. Now I want to know how much area the car has covered. Okay, if it is a circle, I know the area, that is pi r square. If I know rectangle, the area is what? Length into breadth. If I have a square, it is side square. But if I have a curve like this, how to find the area? So to find the area under this curve, we use what? Integration. To find area under any curve, we use what? Integration. Okay, differentiation is what? Rate of change, instantaneous change, all these things. Okay, and also slope of tangent to the normal. If a curve is given, slope of tangent, not normal, slope of tangent to a given curve. We find out what? Differentiation. So for this, if I draw a tangent, slope of it if I find out, that is differentiation. But for this, if I find out the area, to find out the area, I need what? Integration. I take the help of integration. This complete area, if I draw perpendiculars here, suppose I want the area from here to here, I will draw rectangles like this of uniform length, of uniform width. Okay, I call this as dx. Okay, so I will find out this value and I keep on adding. Okay, then finally I will get the area. So you can say, you combine all this and you will get the area. So integration, you can also say it is a summation. It is nothing but what? Summation of the function. Summation of this function gives us the area. So clear? So this is the utility of the integration. Okay, utility of the integration. Now I am talking about indefinite integration. Okay, indefinite integration means what? See here, let me illustrate again. I am talking about indefinite integration. Okay, indefinite integration, because in integration we have two types, one is definite, another one is indefinite. Now first we have to know what is indefinite to understand what is definite. The word itself says indefinite. Suppose see here, this is the curve, this is the curve. If I want area under the curve, I'll find out, obviously I'll find out all the area I'll find out, okay. But suppose I say here there is a point A, here there is a point B. I want only, okay, only from point A to point B, this area I need, okay. I am having a bound, from A to B only I want the area, okay, from A to B only I want the area, that is from here to here only I want the area. This is called as definite integration. You have a proper boundary, that is called as what? Definite integration. That is called as definite integration, which we will be discussing in the upcoming classes. Definite integration, when we have a boundary, that is called as what? Definite integration. For entire curve, when you are finding it out, there is no boundary, means you will find what? That is indefinite integration. Okay, let us proceed further. Let us see the notation of integration. Notation of integration. But before that, you have to know something called constant of integration. Constant of integration. Now see here, when I write d by dx of x square, what is the answer we'll get? We'll get what? We'll get what? 2x. Now, if I integrate this 2x, if I integrate this 2x, I'll write it as what? Integral of this is what? This one. See here, this large s value, or you can say snake like this. This is called as integration symbol. This is the integration symbol, friends. So, integral of 2x, what is the answer we'll get? I'll get it as x square. I'll get it as x square. But apart from x square, something else should also be written. That is called as, I'll write plus c. This is called constant of integration. This is called constant of integration. This c is called as what? Constant of integration. Whenever you do indefinite integration, plus c will come. Whenever you do definite integration, plus c won't come. That is, constant of integration won't be there in definite integration. Please keep this in mind. But in indefinite integration, or if I say integration per se, just if I say integration, definitely constant of integration should come. Why? Let me explain now. Now see here, d by dx of x square is what? 2x. If I write d by dx of x square plus 2, see, derivative of x square is what? This is 2x. Derivative of constant is what? 0. So it will be 2x only. If I write d by dx of x square minus 30a, see, x square is what? 2x. 30a is what? Constant. It will be 0. Answer will be 2x. d by dx of, if I write x square plus 2026, if I write, what is my answer? The answer will be still x, 2x only. 2026 is what? It is a constant value. Derivative of constant is 0. So I will have what? I will have 2x. So when I integrate this 2x, I will write x square plus, if 2x is there, okay, if 2x is there, there may be some constant. 2x is coming because of x square, okay. If it is coming because of x square plus 2, I don't know. Because if there is some constant here, x square plus 2, that is also giving 2x. If I integrate this, I'll get x square. If I integrate this, I'll get x square. If I integrate this, I'll get x square. But here only x square is not there. 2 is also there. Minus 30a is there. Here plus 226 is there. So it can be any value. That value I cannot find out. So for that, what I'll do? I'll just put some constant symbol, that is plus c. Okay, understood. Here x square is there, totally fine. But here x square plus 2 is there, x square minus 30 is there, x square plus 226 is there. So simply if I integrate 2x, I'll get x square. But it may not be just x square, it may be having some constant. To represent that constant, collectively put together, we will write constant of integration, that is plus c. Understood? Now, if I write, suppose I write why x square is coming to integral of 2x dx, I told you it is a reverse process. So reverse process you are getting. But there are certain formulas which you got to remember. But before going to that, let us understand the notation of integration. What does each of it mean? Okay, what does each of the notation means? Now see here, notation means what I told you. In differentiation also you will write it as what? Dy by dx, or you will write it as what? F dash of x, or you will write it as what? Y dash, all these things. Okay, now when it comes to integration, we will write it like this. Integral of, if I say f of x, small f of x, if I am getting it as, here I should write what? F of x, I will write it as what? F of x dx. If I get it as capital F of x, okay, plus c. I told you should have plus c. I am talking about indefinite integration. Here, what does each of it mean? Let us understand. What does each of the notation mean? This is what? This is symbol. This is what? Symbol of integration. This is symbol of integration. Thank you. This is symbol of integration. Okay, this is symbol of integration. So what do we call this? Integral of f of x. What do we call this? Integral of f of x. Integral of f of x. This f of x is what? The function to be integrated. This f of x is what? The function to be integrated. The function to be integrated. What do we call this? This is the function to be integrated. This is called as, the function to be integrated is called as the integrand. Is called as the integrand. The function to be integrated is called as the integrand. Next we have dx. So with respect to what you are integrating? So when I talk about differentiation, if I say dy by dx, you understand you are differentiating with respect to x. If I say dy by dt, you understand we are differentiating with respect to t. If I say dy by ds, you will understand we are differentiating with respect to s. So similarly here you should know, okay, with respect to what you are integrating. So that is why this is called integration. What is it? This is variable and variable of integration we call it. This is called variable of integration. Okay, with respect to what? Variable of integration, or you will say with respect to what you are integrating. With respect to what you are integrating. After integrating whatever you get this function, whatever you get as answer, that is called as, what we get, that is called the antiderivative. That is called antiderivative. Okay, or we can say integral. Okay, antiderivative, it is also called as integral. We get the integral. Then plus c, this is called, I told you constant. What constant? This is called constant of integration. This is called constant of integration. Okay, this is called constant of integration. This is called constant of integration. Suppose I write an example here. If I say integral of x dx, I will write the answer as what? X square by 2 plus c. Here this is the integration sign, this is the integrand, this is the integrand. Okay, and what about dx? This is the variable of integration, this is the antiderivative, plus c is what? Constant of integration. Now let us go to some very important results, or I will say the formulas. Okay, or the formulas. Now before going to examples, let us see some formulas. So if you talk about the formulas, some very important formulas are there which you have to definitely know. Now we know that, okay, I will write the formula here. I hope it is visible. Let me check if I am audible first. Going to examples, let us see some. Yeah, yep, it's fine. Okay. So if you look at the formula, so if we talk about the formula here, so see here, d by dx of, we know that d by dx of, I am writing differentiation formula first. D by dx of x to the power of n, we write it as what? N times x to the power of n minus 1. N times x to the power of n minus 1. Now if I integrate this, I should get what? X to the power of n, because it is a reverse process. If I integrate this RHS, I should get the LHS, that is I should get x to the power of n. So that means what? We have a formula here. Okay, very important results. You have to remember, integral of x to the power of n dx. Integral of x to the power of n dx. Here what we are having, x to the power of n minus 1 is there. Here it is a reverse. So what I should do? X to the power of n plus 1. X to the power of n plus 1. Here what you are writing? You are writing n next to it. Here you should write what? N below it. But not just n, you should write what? Whatever the power is there, x to the power of n plus 1 by n plus 1 plus c. X to the power of n plus 1 by n plus 1 plus c. Clear friends? So if you are having here, observe here, d by dx of, if you are having, let us take x to the power of 4. X to the power of 4 means what will happen? 4 will come down, x to the power of 3 it will become. So similarly, if I take it here, integral of x to the power of 4, integral of x to the power of 4 dx, integral of x to the power of 4 dx, what will happen here? X to the power of 4 will become 5, 4 will plus 1 will become x to the power of 5 divided by what you should do? 4 plus 1, that is, let me write it in a proper way, see here, in a proper notation, this will become x to the power of 4 plus 1 by 4 plus 1 plus c, by 4 plus 1 plus c. What is the doubt? Rakesh Parmar, what is the doubt you are having? X to the power of 4 by 4 plus 1 plus c. So x to the power of 4 plus 1 is what? X to the power of 5 by 5 plus c, by 5 plus c. What is the doubt, Rakesh, you are having? Please put your doubt. So this is what we are having. Now this is the formula for differentiation. Same formula, how it modifies when it comes to integration, did you understand? x to the power of n minus 1 here it will become n plus 1 divided by n plus 1 plus c. Okay, see, just basically remember when we talk about differentiation, whatever we write, we'll write it as a product, 2 times sin x, 3 times cos x. But when it comes to integration, what was coming as a product, that will come in the denominator. 2 sin x will become what? Sin x by 2, like that. Okay, that is a basic thing you have to remember when it comes to integration. Now, let us take some more examples. So, see here, if I am having here, see, if I am having 3 integral of, not integral, let us take differentiation of d by dx of if I have 3x square, what I will do, 3 I will write as it is, x square I will write it as what, 2 minus 1, that will become, here n into 2 minus 1 is what, 1. So, this will become what, 3 2 is 6 x, that is all, you will have 6x, Now, integration of 3x square if I do, what will happen? Integration of 3x square if I do, what will happen? 3 is the constant, I will keep 3 outside. Okay, 3x square dx it should become equal to, this will become 3 times integration of x square dx, Now, integration of x square dx, this will become what? If I apply the formula, integral of x to the power of n dx is nothing but equal to what? This will become x to the power of n plus 1, by n plus 1, and every time, this is not complete, every time you should remember, you should write what? Constant of integration, that is plus c, Now, this if I apply here, this will become 3 into x to the power of 2 plus 1 is what? 3 by 2 plus 1 is what? 3. Is it complete? No, we have to write constant of integration, that is plus c. This 3 and 3 I can cancel, I will have what is the answer? X cube plus c. I will have the answer as what? X cube plus c. Clear, friends? This is how we will do it. Now, what happens when it comes to constant? What will happen? See here. Suppose I am having here, but before going to constant, if I see, if I am having d by dx of x, derivative of x is what? 1. But when it comes to integration, integral of x dx, this will become what? Here 1 is there, that means x to the power of 1 plus 1 by 1 plus 1 plus c. So, this will become x square by 2 plus c, Similarly, if I talk about the constant d by dx of, suppose there is some constant k, d by dx of constant is what? 0. d by dx of constant is what? K, that is d by dx of constant k is what? 0. Now, when it comes to integration, integral of constant k dx is there, or if I say here k I will take it outside, integral of, it will become 1 dx. So, this will become what? Integral of 1 dx is nothing but k into x plus c, By this, what we can deduce? See, if you are having d by dx of 1, d by dx of 1 is nothing but what? D by dx of 1 is constant. 1 is constant means it will become 0. But when it comes to integration, nothing is there. If I write just simply, if I write integral of dx, it is nothing but what? It is nothing but 1 dx. Here dx I am writing, so I should integrate with respect to x. So, the answer will be here 1 dx means I will write what? X plus c. Suppose if I am having integral of dt, means what? Nothing is there means you will write it as 1. Integral of 1 dt means here x is not there, you are integrating with respect to t. So, that means what? You will write it as t plus c. Similarly, if I am having something like integral of 2 ds, So, 2 is what? Some constant value. So, I will write 2, but here nothing is there means it is 1. So, integral of 1 ds is what? Integrating with respect to s. So, what you will do? 2s plus c. Okay, 2s plus c, or basically I can write what? 2 I can take it outside, 1 ds, 2 into 1 ds. Here 1, what will happen here? Whatever you are integrating, that you will write just right here. It will become 2s plus c. So, if I have to write, see here, if I write here another example, integral of dA is equal to what? Integral of dA is equal to what, friends? So, you are integrating with respect to a. So, you just write small a plus c, that is all, small a plus c, clear? These formulas will be helpful. Integral of nothing is there means you should assume it is, not assume, it is actually 1. Integral of 1 dx or integral of 1 ds, whatever the constant of integration is there, that should be written plus c. But along with that, you are integrating with respect to what? That one will be the value of the, what is that? Antiderivative. ds means it will become s, dt means it will become t, dx means it will become x, dz means it will become z, like that. I hope this is clear now with this formula. Now, just based on this formula, let us go to some more examples, or let us see the formulas here. So, k integral of k dx, k is what constant, it will become kx plus c. Okay, integral of x to the power of n dx, x to the power of n plus 1 by n plus 1 plus c, I told you already. Now, this is what, n must not be equal to minus 1. Why? I will tell you. Now, if n is equal to minus 1, what will happen? 1 by x. Integral of 1 by x is what? Log mod x. We know that d by dx of log x is what? D by dx of log x is 1 by x plus c. 1 by x plus c won't come when it comes to differentiation. D by dx of log x is what, friends? 1 by x. But if I do integrate this, I will get this value. That is what we are getting here. Integral of 1 by x dx is what? Log mod x plus c. Okay. So, this, please remember this. What will happen is root x means 1 by root x means you will write it as what? 1 by x to the power of 2 by 3. So, what will happen? This 2 by 3 will go up. So, this will become x to the power of minus 2 by 3. Integral of minus 2 by 3, if you do, you will get 2 root x. So, integral of 1 by root x is what? 2 root x plus c. Integral of root x is what? 1 by 2 root x. Integral of root x is 1 by 2 root x. Integral of 1 by root x is 2 root x plus c. Now, similarly, integral of root x is what? 2 by 3 x to the power of 3 by 2 plus c. Please remember this. Please remember this. Now, integral of e power x. Integral and differentiation meet here. Okay, they say we are not opposites here, we are friends. Okay, integral of e power x or differentiation of e power x is the same. So, integral of e power x is what? E power x plus c. Differentiation of e power x is what? E power x. There is no constant there when it comes to differentiation. Now, see here, integral of a power x. We know that d by dx, differentiation of a power x is what? A power x log a. A power x log a. But when it comes to integration, what will happen? Integral of a power x dx is what? You will write a power x as it is. Instead of writing next to it, I told you in integration it will become to the denominator, whatever the constants are there, this will become a power x log a plus c. A power x log a plus c. This is how we will do it, friends. Now, some more examples. Suppose we are having negative values. Suppose I want to integrate x to the power of minus 5 dx, or if I am having something like 1 by x to the power of 3 dx. Okay, I want to integrate this x to the power of minus 5. That is nothing but apply the same formula, x to the power of minus 5 plus 1 by minus 5 plus 1 plus c. This will become what? Minus 5 plus 1 is what? Minus 4 x to the power of minus 4 divided by minus 4 plus c. So, what will be the answer? This is the answer, you can keep it, or further you can simplify. Now, we are having 1 by x to the power of 3. Okay, the formula is integral of x to the power of n. There is no formula like integral of 1 by x to the power of n, there is no formula. So, integration is all about whatever function is given. So, you modify or you manipulate the function and bring it to a form where you can apply the formula directly. So, integration is all about what? Integration is all about, so for whatever the function is given, you try to modify or manipulate, use some substitution, use some tricks or use some techniques or methods, that is called method of integration. Like how we studied method of differentiation, there is methods for integration also, various methods are there, we will be studying. Okay, gradually we will be studying that. Tomorrow's class we will be studying various methods. Today also we will get introduced to some of the methods, let us see. Okay, so we have to modify the function and bring it to a form where you can directly apply the formula. Can you apply the formula directly? No. So, we will modify it. What we will do? We will bring this x cube upside. If I bring it upside, this will become what? X to the power of minus 3 dx, because 1 by a to the power of n is nothing but equal to a to the power of minus n, that is by law of exponents. If I take it to the up, so this will become x to the power of minus 3 dx. So, if I apply integration formula here, it will become what? Minus 3 plus 1 by minus 3 plus 1. So, once the integration process is done, directly you should write plus c. Here you should not write plus c. So, this is still not yet integrated. In the last step only you should write plus c. So, this will become what? X to the power of minus 2 by minus 2 plus c. This is the final answer, friends. This is the final answer. But suppose I am having integral of 1 by x dx. This is nothing but straight away you should write log mod x plus c. Log mod x plus c. You should write what? Log mod x plus c. Now, when we talk about trigonometric functions, so you are telling about the formula for polynomial functions, fine. When we talk about the trigonometric functions, so d by dx of sin x, d by dx of cos x, these two are the things which will trouble you, okay, because they are very opposite here. You should remember d by dx of sin x is what? We know it is cos x. That's why pay attention here. D by dx of cos x is what? Minus sin x. Minus sin x. Now if I integrate this, definitely I should get this. So if I integrate cos x, I am getting what? Sin x. If I integrate sin x, I am getting what? Cos x, but minus is also there. So integral of sin x will become what, friends? Minus cos x. So which I can summarize and write it here what? I can write integral of sin x dx. Integral of sin x dx is equal to what? Minus cos x. Is it? But we have to write plus c, constant of integration, plus c. Now integral of cos x dx. So integral of cos x, what I am getting here? Sin x, just sin x. So it will become sin x plus c. So whatever in integration we are seeing are completely opposite to what we are seeing in differentiation. D by dx of sin x is what? Cos x. But integral of sin x is what? Minus cos x. D by dx of cos x is what? Minus sin x. But integral of cos x is what? Integral of cos x is plus sin x. Okay. So this is very important. Please remember this, highly important. Highly important. This one, there are chances you will do the mistake. So remember this, very important. The sign will change. The sign will change. D by dx of sin x is what? Cos x. But when it comes to integral of sin x, that is also cos x, but it is minus cos x. D by dx of cos x is what? Minus sin x. Integral of cos x is what? That is also sin x. Instead of minus sin x, you will write what? Plus sin x. That's it. Okay. Now let us see other formulas for trigonometry functions. D by dx of, not d by dx, let us see directly integration formulas. Integral of tan x, integral of secant square x. Let us not do tan x as of now. Let us keep this one, these functions. Integral of secant square x dx, integral of cot square x dx, integral of secant x tan x dx, integral of cot x cosecant dx. Now see here, integral of secant square x is tan x plus c. You have to remember this. Integral of cot square x is, it is minus cosecant x plus c, minus cosecant x plus c. Integral of secant x tan x is what? It is just secant x plus c. Integral of cot x cosecant x is what? It is minus cosecant x plus c. So cot and cosecant come means it will come minus. Okay, it is minus cosecant x plus c. These are the very important results which you have to remember. Okay, that is what is given here, same thing. Okay, log and cot is also given. So integral of tan x is what? Log secant x plus c, or you can also write it as minus log cos x plus c. That is secant x is inverse of what? Cos x, so it will become outside. Okay, integral of cot x is what? Log sin x, log sin x. Okay, remaining things you don't have to worry now. As of now, these basic formulas are sufficient for you. Okay, now inverse functions are also given. No need to worry about inverse functions as of now. Now let us see some examples. Okay, examples how to solve this by using our important results. But before going to that, let us see some methods. See, let us see some properties. Suppose two functions f of x and g of x are two integrable functions, then integration of f of x plus or minus g of x can be written as what? Integration of f of x dx plus or minus integration of g of x dx. Same like differentiation. F of x is an integrable function and k is a number. That means scalar, integration of scalar. This scalar will come out, be it differentiation, be it integration, be it limits. This, what will happen? This k will come out. This k will come out. Okay, that is what I told you. Now, if we are having integration of f dash of x by square root of f of x. Okay, or first thing, remember this one first. Integration of f dash of x by f of x. That is, you are having a function such a way that, suppose I will write it here. I will write integration of tan x is there. Okay, integration of tan x is there. Derivative of tan x is what? Secant square x. Okay, secant square x. So this is of the form what? Integration of, what is this? This is, let tan x be the function f of x. This is f of x. This what? F dash of x is there. So we can write it as what? Log f of x plus c. Log f of x plus c. Log f of x plus c. Next thing is what we are having. Suppose we are having, okay, same thing. If I say, suppose we are having square root of tan x. Okay, here I am having secant square x. Okay, tan x is what? F of x. So this is nothing but what? Integral of square root of, what is this? F of x. In the numerator I am having what? I am having f dash of x. In the numerator I am having f dash of x. So this can be written as what? 2 times square root of f of x plus c. 2 times square root of f of x plus c. This is one very important property you have to remember. Okay, this is one very important property you have to remember. Now let us go to the examples, friends. let us go straight to the examples. Okay, now see here, slowly let us do the examples. They are given x by x minus 1 dx. What is it they have given? X by x minus 1 dx. Okay, so instead of doing these questions, let us do some other examples so that you will have more clarity. Let us do some simple questions, then we will go to these questions. Okay, now they are given x square minus sin x plus 3x dx. X square minus sin x plus 3x dx for entire thing dx. That means you have to integrate separately. You can take it integral of x square dx minus integral of sin x dx. You have to write every time minus this is plus 3 times x. 3x means I can write it as 3x dx. 3 times x dx. Now see here, what will this become? This will become x to the power of 2 plus 1 by 2 plus 1. This will become 3 by 3. So I can write plus c, but no need to write here. For everything, where for this also will get constant, this one also will get constant, this one also will get constant. That is perfectly true. What we will do, instead of writing constant each and every step, what we will do, we will combine everything, collect everything and write it as one single constant. We will write it as one single constant. So we will not write constant here, in the end we will write it. Integral of sin x is what? Integral of sin x is what? Minus cos x. Okay, it is not just cos x, it is minus cos x. But already here minus is there, minus into minus will become what? Plus. Okay, plus, or let me write one more step here. This will become what? I can write this as what? See here, let me use the formula 2 plus 1 by 2 plus 1. Okay, this is what? Minus integral of sin x is what? Minus cos x. Minus cos x. Integral of plus 3 into integral of x is what? X to the power of 1 plus 1 by 1 plus 1. This is entire, after integrating I should write plus sign, plus c. That is what? This is constant of integration. Now this will become what? X to the power of 3 by 3. This minus into minus is plus cos x, plus 3 into what is this? X to the power of 2 by 2 plus c. So this is the final answer, friends. This is the final answer. This is the antiderivative of this function, given function. Now integral of x cube minus 1 by x square dx. Do we have the formula for this? No. So we have to modify this function and bring it to a form where I can directly apply the formula. So see here, we are having simple, just observe carefully, x cube minus 1 by x square dx. For such questions, what you should do? Separate and divide it. Separate and divide it. Numerator you can separate like this, x cube by x square minus 1 by x square. Okay, for entire thing I will do integration directly. X cube by x square is what? See, this will become, if I cancel this and this, I will have only x. Integral of x dx minus, what is this? X square, if I take it up, this will become integral of x to the power of minus 2 dx. Yes or no? Ona kada? This is what you will have. Okay, integral of x dx is what? This will become x to the power of 1 plus 1 x square by 2 minus integral of x to the power of minus 2 is what? Minus 2 plus 1 by minus 2 plus 1 plus c. Once you integrate, definitely we should write constant sign there itself, plus c. Now further we should do this. Okay, further what we can do? See here, what you are supposed to do here? This will become x square by 2 minus x to the power of minus 2 plus 1 is what? X to the power of minus 1 by minus 1 plus c. So what I can do, this one further I can simplify and I can write it as what? Here I will write it x square by 2 minus this minus will become plus x to the power of minus 1. If I bring it down, it will become just 1 by x. Okay, this will become 1 by x plus c. This is the answer, friends. This is the most simplified answer for this question. Now look at this question we are having. Now look at this question, what we are having. They are telling x to the power of 2 by 3 plus 1 dx. Okay, this can be written as what? Integral of x to the power of 2 by 3 dx plus integral of 1 dx. Nothing is there, means it is 1. Integral of 1 dx. X to the power of 2 by 3. I can write it as what? Here n is what? 2 by 3. Just put the values 2 by 3 plus 1 by 2 by 3 plus 1 by 2 by 3 plus 1. This will be what? Okay, after integrating I am writing integral of 1 dx is what? Nothing is there, means it is x plus c. Now simplify this. Here denominator is 3. So if I take LCM, 3 will be the LCM. So 3, 1 3 is, so here nothing is there, means 1 by 1. So 1 3 is, so this will become what? 3. So 3 plus 2, 5. So x to the power of 5 by 3. Here also it will become what? 5 by 3 plus x plus c. Now if this 3 will go up, okay, this 3 will go up, this will become 3 by 5 x to the power of 5 by 3 plus x plus c. This is the final answer, friend. This is the final answer. Similar to the previous question, like this you have to modify and you will get the answer. Okay, I hope it is clear. Let us proceed to the next question. So see here, this is based on trigonometric functions. Integral of sin x plus cos x dx. So see, let us separate and integrate it. This is integral of sin x dx plus integral of cos x dx. Okay, integral of sin x, I know it is cos x. Integral of cos x, I know it is sin x. Okay, but integral of sin x is minus cos x. Okay, integral of cos x is just cos x. Sorry, cos x is just sin x. Okay, plus c. Okay, here plus is there, so plus c. This is the final answer, friend. Integral of sin x is what? You should know the formula. Integral of sin x is minus cos x. Integral of cos x is sin x. But don't get confused with differentiation. Differentiation same thing, but the minus sign will be opposite. Okay, integral of sin x is plus cos x there. Integral of differentiation of cos x is plus cos x. Differentiation of cos x is what? Minus sin x. Okay, here it is reverse. The terminology is same. Sin x will give us cos x will give us sin x. Here it will be minus cos x and plus sin x for cos x. Clear? Now see here what we are given, cosecant x, cosecant plus cot x. So what we will do? We will modify this and we will do what? Cosecant x into cosecant x will do cosecant square x dx plus cosecant x into cot x. I am just multiplying this. Cosecant x cot x, okay, dx. Now see here, integral of cosecant square x is what? It is nothing but minus cot x. I told you the formula, minus cot x. Integral of cosecant x cot x is what? It is minus cosecant x. It is minus cosecant x plus c. So this is the final answer, friends. Clear? This is the final answer to this question. Now let us proceed. They will give like this also. They will not give the integral sign and all. They will just ask, find the antiderivative of sin 2x. Find the antiderivative of sin 2x. So here what we will do? Integral of sin 2x dx. Integral of sin 2x dx is what? It is minus cos 2x. Minus cos 2x, what we should do? Plus c. But is it complete? No. So this x is having the coefficient, what is it? 2x. So this 2 should come down. These 2 should come down. So in differentiation, whenever we are doing d by dx, okay, let me write here. Whenever we are doing d by dx of sin ax, if you are doing, you will write what? Cos ax, okay, and this coefficient of x is what? You will write a here. But when you do integral of sin ax dx, you will write what? Integral of sin ax is minus cos ax, you know that now. Okay, instead of writing a next to it, you will write a below plus c. Okay, a below you will write it and it will become plus c. Okay, please make a note of it. Please make a note of it. Now look at this question. Integral of 2x square plus e power x dx. So what I can do with this question? So this one I can write it as what? 2x square dx plus integral of e power x dx. So 2x square dx, that is nothing but what? 2 into x to the power of 2 plus 1. 2 plus 1 is 3 divided by 3. This is what? Plus integral of e power x is what? E power x only, e power x plus c. That's all. One step you will get the answer. One step you will be getting the answer. Clear, friends? Clear till here? Any doubt? Please put it in the comment section. And please do share with your friends as well. And those who missed the previous classes, who joined new, please watch the previous classes also, so that your concepts become very strong. Okay, all right. Look at this question. Let me take up this question. So what is given? X cube plus 3x plus 5. Let me take up in the next page. Integral of x cube plus 3x plus 5 dx by what is it? Square root of x. Square root of x. Okay. So we are having square root of x. So we know that if I write square root of x, I can write this as what? X to the power of 1 by 2. If I write cube root of x, I can write it as what? X to the power of 1 by 3. Okay. Also I know x can be written as what? Square root of x into square root of x. Okay. Also square root of x into square root of x will be written as what? X. So simply put, if I write 2, I can write this as what? Square root of 2 into square root of 2. So these things are helpful for us here. So see here what I can do. Here also I will separate and integrate it. So this I can write it as what? Integral of x cube by root x dx plus 3 into x by root x dx. I will separate and divide it first, plus integral of, this should be dx should come here, everywhere dx should come. Okay, that is very important, you write dx, plus variable of integration should be there, that is dx should be there. So integral of, what is this? Integral of 5 is there, integral of 5 into 1 dx by what is this? Square root of x, by square root of x. Now x cube by what is this? Square root of x. Square root of x is what? I can write the square root of x is nothing but, I will write here simply put, square root of x is x to the power of 1 by 2. So what will happen? This x to the power of 1 by 2, 1 by x to the power of 1 by 2 is there. So if I take it up, this will become what? X to the power of minus 1 by 2. So this will become what? X cube, okay, into x to the power of minus 1 by 2 dx, okay. Or I can directly write this as what? Since bases are same, the powers I can equate, or let me write one more step, x to the power of 3 into x to the power of minus 1 by 2 dx, okay, integral of x into x to the power of minus 1 by 2 dx plus 5 into what is this? I can write x to the power of minus 1 by 2 dx, x to the power of minus 1 by 2 dx integral. Now this is what? Bases are same, powers I can add it. So x to the power of 3 minus 1 by 2 dx plus integral of x to the power of 1 minus 1 by 2 dx, dx should come down here, dx plus 5 into x to the power of minus 1 by 2 dx, keep it as it is. Now what we are having? X to the power of 3 minus 1 by 2. 3 minus 1 by 2 means what? 2 3 is 6, 6 minus 1 is 5. So this will become integral of 5 by 2 dx plus integral of 1 minus half is what? Half itself, x to the power of 1 by 2 dx plus 5 times integral of x to the power of minus 1 by 2 dx. See, once you are thorough with the concepts and formulas, these many steps you don't have to do, but I am doing all these steps so that you understand each and every step and your concepts become clear. Okay, how to apply this formula I am telling you. So this will become what? X to the power of 5 to the power of 1 by 2. Sorry, this is what? X to the power of 5 by 2. 5 by 2 means what? If I integrate, what I'll have? I'll have x to the power of 5 by 2 plus 1 by 5 by 2 plus 1 plus x to the power of 1 by 2 means x to the power of 1 by 2 plus 1 by 1 by 2 plus 1. This minus 1 by 2 means plus 5 into x to the power of minus 1 by 2 plus 1 by minus 1 by 2 plus 1 plus c we are having. Here 5 by 2 plus 1, that is what? 2 1s are 2. So this will become what? 7 by 2. This will also become 7 by 2. So we will have here, okay, this step I am writing here, this will become what? X to the power of 7 by 2 by 7 by 2. Next what we are having? 1 by 2 plus 1 is x to the power of 3 by 2 by 3 by 2. Now this is what? 5 times x to the power of minus 1 by 2 plus 1 is what? 1 minus half is half itself. So I will have 5 times x to the power of 1 by 2 by 1 by 2 plus c. This is the final answer. Further I can simplify this 2, I can take it up. So this will become what? 2 by 7 into x to the power of 7 by 2 plus what is this? 3. This is what we are having? 3 by 2 is there. 2 into x to the power of 3 by 2 by 3. This 2 will go up means 5 into 2, that will become 10. 10 into x to the power of 1 by 2 plus c. 1 by 2 plus c. So further I can simplify this x to the power of 1 by 2. This is the final answer. Or I can further simplify, I can write it as what? X to the power of 3 by 2 means what? I can write it as x to the power of 1 plus 1 by 2. That is nothing but what? X into x to the power of 1 by 2. X to the power of 1 by 2 is what? X into x to the power of 1 by 2 is root x. Okay, root x. So here I can write it as what? X into root x. Here I can write it as what? Root x. Further I can simplify like this. Let us keep it here. It is enough. Now let us move to the next example. See here they have given integral of 2 minus 3 sin x by cos square x dx. Integral of 2 minus 3 sin x by cos square x dx. So what we will do? We will separate and integrate it. First we have to denominator you are having cos square x. So numerator you separate and divide it by denominator. So this will become what? 2 by cos square x integral of 2 by cos square x dx minus 3 into what is this? I can write it as integral of 3 sin x by cos square x dx by cos square x dx. Now this 2 I can take it outside. This will become what? 2 into integral of 1 by cos is what? Secant. So square is there. This will become 2 times secant square x dx minus 3 I can take it outside. Okay, sin, this is what? Sin I can write it as sin by cos. Cos square x I can write it as what? Sin by cos into cos. I can write it. I want it in the form where I can apply the formula. That's why I am writing it like this. Whenever I get sin by cos square, I can write it as sin by cos into cos x. This is what? Sin by cos is what? Tan. 1 by cos is what? Secant. So this is what? Integral of, this is what? 2 times integral of secant square x dx minus 3 times integral of tan x secant x, or I can write it as what? Secant x tan x dx. Clear friends? Now I can directly apply the formula. Integral of secant square x is what? Tan x. 2 times tan x minus 3 times integral of secant x tan x is what? It is just secant x minus 3 secant x plus c. This is the Final answer, friends. Once you are thorough with the properties and formulas, basic thing you what you have to do is you have to manipulate the question, or you have to modify the question, or you have to use some methods so that you get the function in integrable form, or you can apply the formulas of integration directly. You have to bring it to that form. For that, what we are doing, these are the methods we are following. So here in this step, where you are doing integration, only in this step you are doing integration. Till here what you did, you brought it to the form where you can apply the formula. Here I can apply the formula in this step. In this step I can apply the formula. Clear? Okay, now let us see some methods of substitution. So see, to bring the, I told you, integration is all about what? Modifying the question and bringing it to a form where you can apply the formula. See, for example, if you see here, in this question directly I cannot apply the formula. So I modified this question like this and brought it to a form where I can apply the formula here. Oh, so how to modify for this? How to modify for this? See here, to modify this, okay, we have various methods. In that, one of the method, or very important method, is method of substitution. So method of substitution is very useful. Now let us see that method. Okay, now let us see that method. I'll just give the introduction to that method. We'll continue about that method in the tomorrow's class. We'll do it deeply. Now see here, method of substitution, general substitution. So see here, 2x is there. Here denominator x square plus 1 is there. Okay, x square plus 1 is there. So if I differentiate this x square plus 1, what I'll get? 2x. Yes or no? So here, whatever the denominator is there, try to take that as t. Okay, substitution is what? You will take some another variable. You will take t is equal to x square plus 1. Okay, first thing what you have to remember, key point, most cases denominator take it as t. Take it as t. So t is equal to x square plus 1. Now differentiate both the sides with respect to x. So this will become what? Dt by dx, or I can write it as what? Dt is equal to x square. Derivative of x square is what? 2x. Derivative of 1 is what? 0. So dt by dx, I can write it as what? Dt by dx is equal to 2x, or I can write dt is equal to 2x dx. Dx I'll send it this side. So I am having 2x dx here. So here I am having 2x dx, but 2x dx value is what? Dt. So for this, what I should put the value? Integral of, instead of 2x dc, what I should put? Dt divided by, what is this? Here nothing means 1. X square plus 1 is what? What did I take? X square plus 1 is t. Now what is this? Is of which form? This is of the form 1 by x dx is what? Integral of 1 by x dx is, we know the result, that is log mod x plus c. So this will become what? Equal to log mod t plus c. But people will stop here, but that is not complete. T, what is the value? X square plus 1. Put the value of t, that is log mod x square plus 1 plus c. X square plus 1 plus c. This is the final answer, friends. This is the final answer here. Okay, this is the final answer here. Now look at this question. All of you please look at this question. They have given sin x square, okay, into x dx. They have not given sin square x, that is completely different. See, sin square x or sin square theta can be written as sin theta whole square, and sin square theta is not the same as sin theta square. Here square is only for theta. Here x square is there. Here x dx is there. If I differentiate x square, I will get what? 2x. Here I am having x dx. So I will take what? I will take x square. I will take x square as what? I will take x square as t. So t is equal to what? X square. Differentiate both the sides. Dt is equal to 2x dx. But I want what? I want only x dx value. X dx value I want. So I will do what? Dt by 2 is equal to what? X dx. So now this entire integral will become what? Integral of, this will become sin x square is what? X square is t. X dx is what? Dt by 2. Dt by 2. I will write 2 here. 1 by 2 it will become. Instead of writing dt by 2, I wrote 2 here. So integral of 1 by 2, see 1 by 2 integral of sin t dt. Integral of sin is what? Minus cos. So I will write it as what? 1 by t, okay, minus 1 by 2, what is this? 1 by 2 minus 1 by 2 cos t plus c, but t is what? X square. So this will become minus 1 by 2 cos of, what is this? X square. Cos of x square plus c. Cos of x square plus c. This is what it will become. Cos of x square plus c. Okay. Now let us see some more questions. See here we are having integral of tan power 4x secant square x dx. So The previous questions which we saw, we are having the function of the form, this is of the form integral of f dash of x by f of x is equal to what? Log f of x plus c. We got what? Log f of x plus c. Now see here we are having sin of x square x dx. Now here if you see we are having integral of tan power 4x secant square x dx. I know that integral of secant square x is tan x. So here what I should take t? So here let me take t is equal to what? Tan x. Okay, if I take t is equal to tan x, I want to remove secant square x dx. So this will become what? Dt is equal to secant square x dx. Dt is equal to secant square x dx. So directly I cannot differentiate this, not integrate this. So what I should do? I should take some value. We will always take whenever tan comes, whenever tan is there, tan and secant is there, tan and secant is there. Okay, always take tan as t. Okay, this is the key point. Okay, tan and secant combined, if it is there, take tan as t. So you will get what? Secant square x dx. What you should do whenever you have tan and secant x? Okay, take tan as t. So previously what I told you, whatever is in the denominator, take it as t. Okay, next second point what I am telling, whenever tan and secant are there, take tan as t. Suppose we have cot and cosecant, you should take cot as t. Okay, tan and secant, take tan as t. Cot and cosecant, take cot as t. So see here, this is what I told you. So this will become secant square x dx. Now what will this become? The function will become integral of, what will happen? Tan is not there. Instead of tan, what did I take? T. So this will become t power 4. Secant square x dx is what? Dt. T power 4 dt. So I will have what? T power 4 dt. These are for which formula? X power n dx formula. So this will become what? X power n plus 1 by n plus 1 plus c. So this similarly this will become what? T power 4 plus 1 by 4 plus 1 plus c. So that is what? T power 5 by 5 plus c. Is that it? No. We have to substitute the value for t. T is what? Tan x. So I can write this as what? Tan x, or I can write it as tan power 5x divided by 5 plus c. This is the final answer, friends. This is the final answer. So this is how you can solve this question. This is how you got to solve this question. Now look at this integral of 1 by x plus x log x. 1 by x plus x log x, directly you cannot integrate. So in such cases you can see whether you can take something common. So first, next important point is, third point I am talking about when it comes to integration by substitution. Take common and put whatever is inside bracket as t. Put whatever is inside brackets as t. Okay, so if I take common, what is common here? X and x. Here x is common. I can do what? Integral of 1 by, I can take x outside into x into 1 plus log x. X into 1 plus log x dx. Here dx should come. Okay, here dx should come. See here, integral of 1 by x plus 1 plus log x dx. Now what is within the bracket? 1 plus log x. Simply just put t is equal to what? 1 plus log x. T is equal to what? 1 plus log x. Now differentiate both the sides with respect to x. Dt will become what? Derivative of 1 is what? 0. Log x is what? 1 by x. 1 by x dx. Now you may be thinking, where is 1 by x dx? See here, 1 by x dx is here. If you observe, 1 by x dx is here. So 1 by x dx is what? Dt. So 1 by x dx, this will become what? I can write this as what? I can write this as 1 by x dx is what? Dt. But what about this bracket? This bracket is what? T. This will become 1 by t dt. So integral of 1 by t is what? Log mod t. So this will become log mod t plus c. After integrating, definitely we should write what? We should write constant of integration plus c. So but t is what? In the final step we have to substitute for t. Whatever you put the value of t, that you have to put it in the final step. So this will become what? Log of 1 plus log x. Log of 1 plus log x plus c. So this will be the final answer. So this will be the final answer, friends. Okay. So in today's class we learnt basically what is integration, what is the meaning of integration, and what is the application of integration, that is area under the curve, to find the area under the curve. And we learned various formulas, important results, and based on that we solved some example questions. And also I told you integration is all about modifying the given function into a form where you can directly apply the formula. Okay, for that we need various methods. So one of the methods we discussed, that is method of substitution. I have just given introduction to method of substitution, but I have not yet completed. Okay, method of substitution, there is trigonometric substitution also, all these things and various other methods we will be discussing in the tomorrow's class, friends. So tomorrow's class is of utmost importance, you have to, if you have to understand integration very well. Okay. So today's class, please watch it again. If you have any doubt, you can put it in the comment sections, and please do share with your friends. Okay. Tomorrow we will be doing other methods of integration. First we will start with what method of substitution, and then we will be going to other methods, and we will also solve some JEE Mains questions or EAMCET questions or any KCET questions that have come from integration. Alright friends, thank you. Let's meet in the tomorrow session. Take care.